Hey folks, for this IXL skill, we are going to need to use some software to get the job done. It's just very difficult to do this calculation by hand. Hopefully by now I've already had you try to use your gut to try to figure out approximately what the correlation coefficient is for some scatter plots. We went through some examples, and hopefully we got an idea of how to estimate approximately what a correlation coefficient would be. Now we're going to take a look at what is the actual calculation. So if you take a look at how they explain it in IXL, you can see that the explanation is rather complicated. Okay. The good news is that most people, when they do this calculation in the real world, they use software. Now, it turns out that even to use the software, it's going to require some math knowledge or math understanding on your part. So we're going to take a look and see how we can use the software to analyze this data. So I just pulled up one of the random problems in this skill, calculate correlation coefficients, and it says find the correlation coefficient R of the data described below. Jackie works with a property developer building houses close to the coastline in Italy. Ooh, that sounds exciting. Her boss thinks that the demand for the houses will be based primarily on their size. So Jackie wants to show her boss that proximity to the ocean is also a big factor to consider. So she looks at several houses of the same size in the area, and she records the distance of the house from the ocean, and she calls that X, so it's obviously these numbers. She also notes the number of people who offered to buy each house, and she calls that Y, and it's these numbers, and when it was last put up for sale. Okay. She also notes the number of people who offered to buy each house when it was last put up for sale. Okay. So two sets of numbers. One is how far from the ocean. The other one is how many people offered to buy the house. This 4 goes with this 7, and this 13 goes with this 11. All right. Now, we're going to go ahead and try copying this data. I'm going to go ahead and, I'm actually going to copy the whole table initially, but I may change that in a second. And we're going to look at two different ways to solve this problem. One way, we're going to use Google Sheets. So we're going to go into Google Drive, and when we're in Google Drive, we'll go New, Google Sheet, and when the new Google Sheet comes up, we'll name it correlation coefficient or whatever you would like. Then I'm going to go click in one of the cells and do Control V to paste. And it gives me the name of each column, and it also gives me the all the data. Now, one thing before we dive in and look at the correlation coefficient, to me as a statistics teacher, I think it's really important that we also be able to visualize the data. So I'm going to highlight all the data, including the names of the columns, and I'm going to say Insert Chart. And then we can actually see the dots plotted out on a graph. And then if we wanted to, we could even go and we could do a trend line through the data. Now, when we look at this trend line, I have to say, this trend line, I don't know if it's really a great representation of all this data. It almost looks like there's not really a real strong trend there. But nevertheless, they want us to find the correlation coefficient, so we'll try to do it. I'm just giving you a heads up that when people are in the real world examining data, we look at more than simply the correlation coefficient. And in this case, I would wonder whether the correlation coefficient actually had a lot of meaning. Anyways, let's get back to the data. If we want to calculate the correlation coefficient, we really didn't need these top two pieces of information. For the correlation coefficient, we type equals and then CORREL. And by the way, you might be wondering, does it matter what cell I type this into? No, it does not. I could have typed down here or over here or up higher, whatever. Anyways, I do open parentheses. Oh, and by the way, you'll notice when I begin to type correl, C-O-R, it is the only thing that comes up. So I'll just keep typing and then open parentheses. And then, strangely, when you go to get the correlation coefficient, you have to provide the formula with the Y data first, then the X data. And so what I'll do is I'm going to use my mouse to highlight the Y data, and then I'm going to put a comma in there, and then highlight the X data using my mouse again. And then I'm going to go ahead and close the parentheses and hit enter. And when I do, I get this calculation. Yay! And we'll try to zoom in a little bit for you guys so that you can see it nice and clear. That's a little bit bigger. The other thing is in IXL, they're asking us to round our answer to the nearest thousandth. Nearest thousandth. Wow, that's hard to say. Anyways, when I go to try to do it, I see that I get a lot of decimal places. So the question for you is, what is the nearest thousandth? Well, it means the third decimal place, okay? I'll remind you that when you look at this, it's not going to let me, dang it. Okay, when you look at this number, negative 0.239119, I'll just go that far. When we look at that number, and we go and we look at just the 2, that is the 10th place. When we look at the next number, that is the hundredths place. And when we look at the third digit, that is the thousandths place. Okay, so that's why we know we got to get to the third decimal place. Now, if you're good, you can round to that third decimal place. On the other hand, if you would like to take advantage of modern technology, there's a button up here. One of these buttons gives you more decimal places and one gives you less. I'm going to go and try one of them, and it looks like I figured out the right one. It looks like it's the one that goes to the left. And I keep doing that until I only have 3 decimal places left. Now, if I accidentally go too far, I can click the one to the right and it'll expose that third decimal place. And now I don't need to worry about rounding incorrectly. So let's go ahead and try plugging this in. By the way, you'll notice it's a negative 0.239, and that usually means that our trend line had a negative slope. And if I recall correctly, a minute ago when we drew the trend line, it was a negative sloping line. Oops, am I doing that properly? I can't remember whether I don't know whether I have the correct, forget it. I'm not going to do it with my hand. Okay, so let's go negative 0.239 and let's see how it goes. Negative point, oh, wait. You know what? We're only 7 minutes in. I'm going to show you another way because I'd like you to double check before we enter that answer. So we're going to also take a look at Desmos. And the good news is with Desmos, we can also copy and paste this information in here. Except this time I'm not going to copy the header titles. I'm just going to copy the numbers. I'll highlight them. Control C on a Mac, Command C. And then I'll go to Desmos and I'll click here and then Control V, or on a Mac, Command V, and I get a table. Yay! And then we're going to have to do, let me make sure you can see the dots so you can see where they're at. And again, the dots look like they're spaced the same way we saw them in the Google Sheets chart. And then we're going to do a line of best fit, which you and I have done before. This is a refresher. And we do Y1 tilde. That tilde key you can find on your keyboard up to the left of the 1 key on the keyboard. And then MX1, because we believe this is a linear relationship, and then plus B. And when we do that, Desmos figures out the line of best fit for us, sort of like Google Sheets did just a minute ago, and it draws the trend line. And again, we can see, I'm not totally sure this trend line really fits this data perfectly, but I know IXL wants an answer, so we're going to get it this time, okay? In the future, if you and I are working together, we can talk about whether or not we really want to use that trend line for that data. Let's see. Now, they say that their R is going to be negative, and by the way, you'll notice the trend line is negative. So their correlation coefficient is going to be negative 0.2392, and we saw negative 0.239. I'm just curious if we go one more out. Oh, good. They also agree on the 2. Great. Okay. So anyways, so now I feel more confident that between Desmos and the correlation, between Desmos and Google Sheets, I think we've got a good answer. So it should be negative 0.239. Negative 0.239. And some of you might be wondering, do we need that 0 at the beginning? Well, no. But if you want to, you can throw it in there. Certainly won't make it wrong. Just don't put an O by accident. And let us pray. Take a moment, breathe, and hit submit. Yay! Okay, so that's the trick, guys. You're going to copy the data. You're going to paste it into a Google Sheet. And then you're going to use equal corr. Make sure that you put in the Y data first. and then comma the x data for some strange reason. I don't know why it's y then x, but it is. And then you're also going to paste the data in here. We'll go ahead and clear all this out. You'll clear all this out, and you'll paste the data into the table there. And don't forget y1 tilde mx1 plus b, and then you'll take this r value here. And again, make sure that you compare the Google Sheets with the Desmos. All right, guys, that is it. If you can do this, this is some super sophisticated use of math in the real world. So, good luck.